The car didn't begin as a finished idea. It didn't roll out of a factory. It didn't arrive fully formed, and it certainly wasn't something people immediately understood. It began as a question, a quiet one at first. What if movement didn't depend on something alive? For thousands of years, every form of land transportation relied on animals. Horses carried people. Oxen pulled loads. Entire cities were designed around the needs of these animals, feeding them, housing them, cleaning up after them. And there was always a limit. No matter how strong the animal, no matter how skilled the rider, speed, distance and endurance all had a ceiling. That limitation sat in the background of human progress for centuries, until a few people decided to challenge it. One of those people was Carl Benz. His story doesn't start with success. It starts with pressure. After losing his father at just 2 years old, Benz was raised by a mother who believed deeply in his potential. She invested everything into his education, pushing him toward engineering at a time when technology was still finding its place in the world. Benz became fascinated with engines, machines that could generate motion without fatigue. But his path wasn't smooth. He struggled financially for years. His early businesses failed. At times, his inventions seemed impractical, even pointless to the people around him. But he kept going, because he believed in something most people didn't yet see: a self-powered vehicle. In 1885, that belief turned into reality. Benz created the patent motor wagon, widely recognized as the first true automobile powered by an internal combustion engine. To understand how revolutionary this was, you have to understand what was happening inside that machine. At its core was a combustion process, fuel mixing with air, being compressed and ignited inside a chamber. That ignition created a controlled explosion. Not chaos, but repeated timed bursts of force. Those explosions pushed pistons up and down. The pistons turned a crankshaft, and that rotation became motion. It was the first time that process had been successfully applied to a vehicle designed to move people. No horse, no external force, just controlled energy. But invention alone wasn't enough. People didn't trust it. They didn't understand it. And many didn't see the point. That's where one of the most important figures in automotive history steps in, not as an inventor, but as a risk-taker. Bertha Benz. The wife of Carl Benz didn't just support the invention, she proved it. In 1888, without telling her husband, she took the motor wagon on a journey over 60 miles long. At the time, this was unheard of. There were no gas stations, no repair shops, no road systems designed for cars. Along the way, she solved mechanical problems herself, invented practical fixes, and essentially created the first roadmap for long-distance driving. That single journey turned the car from an experiment into a real-world machine. It showed people this wasn't just an idea. It worked. At the same time, another mind was working toward a similar goal: Gottlieb Daimler. Daimler wasn't focused on the full vehicle the way Benz was. He was focused on power. He wanted to build a small, efficient, high-speed engine that could be used in multiple ways, not just cars, but boats and eventually even early aircraft. Working alongside Wilhelm Maybach, Daimler developed engines that were lighter, faster, and more adaptable than previous designs. Together, their work helped shape the direction of modern engine technology. What's interesting is that Benz and Daimler never collaborated directly, but their ideas merged through the industry that followed. Still, even with working cars, there was a major problem. They were too expensive, too complicated, too rare. Cars existed, but they weren't changing the world yet. That required a different kind of mind. Not just someone who could invent, but someone who could simplify. That person was Henry Ford. Ford didn't grow up wealthy. He grew up on a farm where life was defined by physical labor and long hours. And from a young age, he saw inefficiency everywhere. Machines to him weren't just tools. They were solutions. Ford believed that if you could build machines better, you could improve people's lives on a massive scale. But when he looked at cars in the early 1900s, he saw a problem. They were built slowly, by hand, and that made them expensive. So Ford didn't just build a car, he rebuilt the process. In 1908, he introduced the Model T. It wasn't flashy. It wasn't designed to impress. It was designed to work. Durable, simple, and built for real-world conditions. At launch, it cost around $850. Still a significant amount, but far less than competing vehicles. But Ford had a bigger plan. He introduced the moving assembly line. And this is where everything changed. Before the assembly line, building a car required skilled workers assembling an entire vehicle piece by piece. It took over 12 hours. Ford broke that process down into steps. Instead of one worker building a whole car, each worker performed a single task repeatedly as the car moved down a line. It was faster, more consistent, and dramatically more efficient. Production time dropped to about 90 minutes per car. That single innovation didn't just change cars, it changed manufacturing across the world. As production increased, costs dropped. By the 1920s, the Model T cost less than $300. And for the first time in history, average people could afford personal transportation. That's when cars stopped being rare and started becoming essential. But as cars spread across the world, they didn't just change transportation. They changed everything around them. Roads had to be built and expanded. Cities began to stretch outward. Gas stations, repair shops, and entire industries formed around the automobile. And as demand grew, so did the complexity of the machines themselves. A modern car is no longer just an engine and wheels. It's a system, a highly engineered combination of mechanics, electronics, and chemistry. Inside every car are between 20,000 and 30,000 individual parts, each one designed for a specific role, each one critical. At the center of a traditional vehicle is the engine. Inside it, pistons move thousands of times per minute. Temperatures can exceed hundreds of degrees. Metal components operate under constant stress. And without protection, the entire system would fail almost instantly. That's where oil comes in. Engine oil is one of the most important substances in a car. It flows through the engine, coating moving parts in a thin layer that reduces friction. But it does more than that. It absorbs heat, it traps contaminants, and it prevents direct metal-on-metal contact. Without oil, an engine wouldn't last more than a few minutes under operation. It would overheat, seize, and destroy itself. Transmission fluid plays a different but equally important role. Inside the transmission, gears engage and disengage constantly. This fluid ensures smooth shifting, reduces wear, and in automatic transmissions, helps transfer power through hydraulic pressure. Without it, the car wouldn't be able to change speeds effectively. Coolant manages temperature across the entire system. Engines produce extreme heat, and without a way to regulate it, they would fail quickly. Coolant circulates through channels in the engine, absorbing heat and transferring it to the radiator, where it dissipates into the air. This constant cycle keeps the engine within safe operating temperatures. Brake fluid operates under pressure. When you press the brake pedal, that force is transferred through brake fluid to the braking system at each wheel. It's what allows a small movement of your foot to stop a multi-ton machine. Without brake fluid, stopping power disappears. Even smaller systems rely on fluids. Power steering fluid helps reduce the effort needed to turn the wheel. Differential fluid protects gears that allow wheels to rotate at different speeds. Every one of these fluids plays a role in keeping the vehicle stable, responsive, and safe. Now multiply that complexity by scale. Because today, cars aren't built in a single place. They're built across continents. Parts are manufactured in different countries, shipped globally, and assembled in highly coordinated systems. Factories use robotics for precision tasks, welding, painting, assembly, while human workers oversee quality, integration, and problem solving. When a car reaches final assembly, it takes roughly 18 to 35 hours to complete. But that doesn't include the thousands of hours spent producing each individual component beforehand. And the result of all that effort? Over 1.4 billion cars on the road today. Each one a product of over a century of innovation. Each one built on ideas that started with a simple question. From Bertha Benz proving a machine could move on its own, to Henry Ford making that machine accessible to the world, to modern vehicles filled with technology, safety systems, and global engineering, the automobile has become more than just transportation. It's become part of how society functions. And even now, the story isn't finished. Because the same question that started it all is still being asked, just in a different way. What's the next way we move forward?